Hi everybody, my name is Pat Hogarty and welcome back to California Real Estate Principles, Real Estate 300. This happens to be show number 30. After today we'll have 2 more shows to go and then we'll be finished with the class. As I mentioned several times during our broadcasts, when I've done my calculations, we end up with 32 shows. What we're going to be doing today is discussing something called real estate math. A couple things that I do want to mention to you. I don't know how well this is going to come across, but what my personal experience has been is that normally when students are taking the class, at least through me, once you've done the study guides or you've been working and you've kind of gotten the rhythm what we need to do, you're working along, your grades are doing really well, and then you get to the last exam that we have for this particular class at least. And all of a sudden, your grade or your last few questions on the exam goes like this. And the reason why is because of the math. And the reason why that happens is because it's unlike the other parts of the book, where I've maybe given you a question, you've been able to study the material, look the answer up, find a precise answer. In this case, you're actually having to work through a problem. And as a result of working through that problem, you develop the answer. And the funny thing is like any other exam that they're going to give you, they've worked pretty doggone hard, or we have, at finding answers that will be correct, but maybe they're not the correct answer because you have taken the wrong approach to figure out the problem. And as I've mentioned many times in a lot of different classes, the math is one of the areas in which sort of the rubber meets the road, or in which you really have to, you learn all this theory, but it's really sort of like the application of that theory. And let me give you an example. You go out and, you studied all this stuff. You get your real estate license. You're working with a real estate broker. You go, somebody calls up and finally says, "Excuse me, could you come out here and help me sell my house?" And you go out there and after you've done all of your initial evaluation and tried to figure out what the houses in the area are selling for before you go out, and you probably contact the title company, and you can do that online and find out, who owns the property, where the school districts, all that kind of stuff is. You finally get out to the client's house, you meet them, you shake their hand, you give them your business card, you go in, and usually within about 15 or 20 minutes, they're going to ask you one question, and that is how much can I sell my house for? And in reality, what they're realistically asking you is, how much am I going to be able to walk away from this transaction with money in my pocket? How much is that going to be? And what you're going to do is you're going to find out, you're going to have the old calculator out. You're going to be doing a lot of different math. That math is going to be involving a lot of different problems. Some of them are going to be trying to figure out how much taxes the people have already paid, maybe what they're going to get back. Maybe you're going to be figuring out things like the escrow fees, the title fees, which are all basically, by the way, are based on the sales price of the property. You're going to be figuring out what the cost of things like loan fees are going to be, if your seller is going to agree to pay some points. The bottom line is you're going to be working with your client to develop this thing called a net sheet, figuring out essentially how much they're going to be able to walk away with. Conversely, and that's a very important figure, because once you've calculated that figure, your client is making a decision, number one, whether to sign up with you or not, and number two, whether the price and the terms that you've set forth in that listing agreement are correct. So math becomes important. Okay, math becomes crucial. It becomes critical. That's what your clients are going to use to make their decision on. Conversely, when you're working with a buyer, you're going to be showing them a lot of properties, taking them around. They're finally going to be doing something, hopefully, as a result of all that effort, called making an offer. Guess what? Before they make an offer, there's something called a buyer's net sheet, in which you're going to be figuring out things like, what is your monthly payment? What are your taxes going to be? What are your escrow fees, your title fees, all that? The point that I have to make here is that this is critical. This math is critical. Whether you may know how to convert the decimal points correctly, what the percentages happen to be, how to figure the facts out is really critical because your client is making decisions based on that. So this is a very, very important part of real estate, an important part of this math. The other thing, too, is to keep in mind that when you explain these math issues to your client, you're going to have different kinds of clients. You're going to have some people that are going to say, oh, I'm an engineer. I teach math on the weekends, okay, or we deal with this. I figure it out all the time. You're also going to have people that maybe haven't done math problems in years. And you're going to have to be able to explain this stuff to them in language that they can understand. Not that there's anything wrong with them, it's just the fact they don't do this on an everyday basis. So if you're going to sit down and explain a lot of very complicated math issues with them, you're going to go right over their head, their eyes are going to cage, they're going to glaze over, and that's going to be the end of that. So anyway, math is important. What's important is that what we're going to be doing in this chapter is I'm going to be explaining the bits and pieces as I normally do as we go along. Probably not this time, but the next time I'm going to be going through the math problems at the end of the chapter. Now, of course, you already know the answers to that. The answers are there. The issue is going to be how do you go about resolving the problem? Not necessarily what the answer is. I mean, I can never think of where a client calls you up and asks you a question that involves math and you say the answer is B and they say thank you very much and they move on down the road. What happens is that you have to figure out what is the best approach to figure the problem out. You're also going to be given information in a lot of different ways. People will talk about monthly payments, weekly payments, yearly payments, annual percentage rates, all kinds of stuff that you're going to have to figure out how to make all the adjustments so that you're comparing, if you will, apples to apples. Very important fact. As I mentioned before, you don't want to get in front of the judge, a year after the transaction has gone by and said, Your Honor, I'm sorry, that the client lost $20,000 or $30,000. I really didn't do the math problem correctly. And they're going to say, that's really good. I'm glad you're honest and truthful and step up to that. The thing is guess what? You're going to pay the $20,000 or $30,000 that the client lost on the transaction because you did the math wrong. Okay, so math is very important. So with that little bit of a yakety-yak lecture, what I'm going to do is be moving back and forth now several different places. I'm going to be moving from my document camera over to the screen. I'm going to also be pulling up something called the Microsoft Windows calculator to do some calculations to show you how certain things work. So I'll be moving back and forth as we go through this. So I'm going to go ahead and pull this up. And the first thing that I want to emphasize to you is within the book itself, they give you certain things called measurements or things that you typically are going to run into. As I've mentioned before in different kinds of fields, there's things that you take yourself for granted that you know, depending upon what kind of an occupation you're in. For example, if you're a medical person and you take blood pressure every day, you understand when a client or a patient's blood pressure is too high or too low. You know what those readings are. We as normal consumers don't know. Okay? Same thing if you're a pilot. You understand, hey, wait a minute, I'm not dealing in miles per hour, I'm dealing in knots. The point is there's terms that you know. And so in the real estate business, there's things that you need to sort of just get a handle on and if for no other reason is memorize. Now, the first thing is some of these things, and some of them are going to seem to be stupid, but I'll explain why it's important for you to know this. First of all, measurements. Linear means in a straight line. Okay? So we normally here in the United States, we're not on the metric system. We're just on the straight inches and feet type system, okay? And so what we need to do is we need to know that, 1 foot is equal to 12 inches, 1 yard is equal to 3 feet, 1 rod is equal to 16 and a half, and 1 mile is 5,280 feet long. Now you may say, wait a minute, I grew up here, I understand that. All I have to really say to you is look around your community. Look at all of the people that are moving in here from other countries. We are one of the last, if not the last country that is not using the metric system. So what people are dealing with, and if you ever want to do that, watch the TV sometime and you'll get to the point where people will talk at so many meters. And you go, well, what is that? Okay, so we may very well have clients that we're having to explain the size of the building and maybe convert it from feet to meters or meters to feet. Very important. The next thing that we're going to need to know is something where we talk about a square. So we need to know that a square foot is 144 square inches, 12 by 12. The square yard is 3 feet by 3 feet. That happens to be something that usually we see things in yards like carpeting, flooring, things like that. An acre. We always are presented this. You look in the newspaper and they say a half an acre, quarter of an acre, 2 acres, 3 acres, 5 acres. How big is that? If somebody says to you, my property I'm selling is a quarter of an acre, well, how big is a quarter of an acre? Well, square footage-wise, it's 43,560 square feet. That's how big it is. That's how big an acre is. So we need to know what that is. We also need to know how big a square mile is. And the reason why is so that we can do, if you will, the math. We can take a look at the property and say, when they tell us it's a half an acre, we can visually draw in our mind where the limitations of that property happen to be. A couple other things that you want to know about that we'll talk about is things called cubic measurements. Cubic means that we're looking at length, width, and height. You may say, where in the world do we ever deal with that? Typically, I would say it's in the area of storage, warehousing space. Just because you're taking this class doesn't mean that you're prohibited from doing commercial property or industrial property or whatever. And what will happen is you're talking about how much stuff you can put into an area. So, for example, if you go down to rent like a mini warehouse to put your stuff in because you're moving, you're going to be concerned about the length, the width, and the height. Okay? And you'll be talking about cubic feet. So that's where you'll really run into that. And then finally, in the area of land description, which goes back to where we did in the beginning of the chapter, we have these other kinds of measurements like lengths, rods, chains. The reason why we do that, and let me explain this for a minute. Is Bob there? Yeah, Bob's there. These other measurements like lengths, rods, all of those things, chains, if you think about it, you can come up with a lot of different types of measurement devices. Okay, so what it amounts to is over the years, people have come up with different ways of measuring things. Again, lengths, rods, chains, miles, meters, whatever. So, for example, this is a silly, stupid example, but I could come up with something and say, I'm going to come up with a new measurement called pencils. And I could say, this is the length of a pencil right here, and I can define that. And I can say, I'm going to sell you something that's half a pencil in length. I could tell you that I could lay this end to end, and I could say this room is, 50 pencils wide by 100 pencils long. That would be a measurement device. Okay, so consequently, when we have these other types of devices, it's just that somebody came up with what they thought was the best way. What we have to be able to do is look at these measurements and be able to convert between them. Okay, most of these you'll see in possibly older legal descriptions, and I'm probably, if we've dug up a surveyor or a licensed civil engineer who's doing surveying, probably could maybe come up and say, I ran across that legal description in this area, because usually they're the ones that somebody wants to divide property and gets this old legal description, and they're having to figure out where are the boundaries of the property, so that they're having to interpret that. Okay, so anyway, you need to know that. You also need to know some of the other measurements, such as we mentioned before, the acre. Remember with townships were 36 sections. Each township was 6 miles by 6 miles. There's 36 sections in a township. You may say, well, why is that important? It's because we may get one of those legal descriptions that'll talk about the northwest quarter, the southwest quarter, the east half of section 29 of a certain township in a certain range on an exam, and they'll say, if the property is selling, based on that legal description, if it's selling for $500 an acre, what is the sales price? You have to know what all those measurements happen to be. That's where the legal description comes in and is important. Another thing that you're going to need to know measurement-wise with legal descriptions is a circle. That, when we talk about, we're talking about direction like a compass, that there's 360 degrees in a circle. And each one of those degrees is broken down into minutes and seconds, okay, so that we know incrementally, so we can say that something is, 29 degrees, 30 minutes, and so many seconds, so we know what the angle is that's involved. That's another legal description kind of a thing. Quadrant is 1/4, if you will, of the circle, okay, quadrant, okay. A degree, 60 minutes, and a minute is further divided into 60 seconds. Now, what you need to do is you just need to know this stuff, okay? You can always look it up, whatever. Will you see it on a real estate exam? Who knows? I mean, it's been a while since I took a real estate exam. I couldn't tell you whether or not I saw that on the state exam. I can tell you that you'll see it in books that help you prepare for the state exam, but it's stuff that you just need to know so that you know that they exist and how you can convert, just like we do when we cook. We go from ounces to quarts to pounds to gallons. We need to be able to do that conversion if we're a cook. Same thing here. Okay, moving on from there. Again, what we need to do is cover some basic conceptual ideas, and that is, again, because we may very well have a client that may or may not be familiar with this. Figuring out just the size. Typically we are involved in doing things like figuring out the size of property, like an acre, or the size of a lot, the size of a house, the size of a room. Now, one thing I do want to caution you about, and probably your real estate broker is going to also caution you about this, is don't put down that the room is exactly, 300 square feet or 200 square feet. The reason why, as I've mentioned in many classes before, I could give everybody a tape measure and a piece of paper, and I could turn you loose in this particular room. I could take 20 people, and I would probably stand to reason you would all come back with a different type of measurement. Some of you may measure from wall to wall. Some of you may measure from baseboard to baseboard. If there's a closet in the room, some of you may include the closet, some of you may not include the closet. If you're looking at measuring a house, some of you may think that, hey, the garage is part of the livable space. Some other people may say no. So the point is that when you sit down with your client and you're putting this into a listing agreement, you may help your client confirm the size, but what it is that it's reported. What most brokers will tell you that it's the square footage as reported by the client, okay, or by the county or by the city or whatever, because they'll have square footage, which, by the way, in some cases may not even be accurate. That may have been the square footage at that time, but the house was added onto and they didn't add the square footage. Okay, just so you know that. But to figure out square footage, again, it's just width times length, however you want to look at it. This is a very easy one because there's no angles involved that we're dealing with. We just say it's 50 feet by 100 feet. We do the length times the width, comes out, and it tells us, if we have 100 feet times 50 feet, it's 5,000 square feet. End of discussion. Pretty simple, pretty straightforward. No angles, nothing to worry about. Pretty easy to follow. We also have times in which we have an irregular lot. Now look at the fact that this thing that we're learning about, this square, is one of the tools. One of the tools. So when we get ready, and you'll see in a minute, when we get ready to measure a property, because we're trying to explain it to a client without using trigonometry, what we're doing is we may break things down into squares, rectangles, and triangles in order to explain the measurement. The next thing that they show you in here is how you take a triangle and you figure out the square footage of that. Now I'm going to show you a formula, and then I'm going to show you something that I think is fairly simple. Okay. This is a triangle. Notice that when I put the line down here, this is what we call a right triangle. A right triangle means that the angle of the triangle, if you take a look at it, if we cut it in half here, this angle right here is 90 degrees. Okay? So just so you're aware of that. What we're saying is that if we want to figure out the area of this triangle, and this happens to be something, the way the house is constructed, the angular structure, we figure out the base of the triangle, which is 150 feet, the height of the triangle, which is 100 feet, and then we apply this formula, which is the area is equal to the base, which is this, times the height, which is this, divided by 2. If you look at it very carefully, this triangle is really a rectangle. Okay, and to give you an idea, if I'll do it like this. If Bob can come back to me on the camera. Here is a triangle. This is the right triangle. Okay, and we said that what we're going to do is when we do this, we're figuring out this section of it. If you really take a look at it, why that makes sense is when I fold this thing out like this is really a rectangle. Okay, So what we're doing is we're taking something that's a rectangle and we're drawing a line through it, which is creating this thing called the triangle. That's why it's 1/2 the base times the height is giving us that answer. Hopefully that makes sense, okay, when you look at it. Okay, so we've got that. The next thing that we want to do is, let's say, for example, we're going out to measure a house. We're getting ready. In fact, sometimes the way appraisers will do it is they may measure let's just say we're going to measure the outside of the house. Okay? So what happens is we go out to this house, and if you can sort of visualize how this, may look, this was probably something like a ranch-style one-story house, okay, that has a living room and a family room, and it has this one oddball triangular-shaped room on it, okay, and they're just doing this for illustrative purposes. So you're going to take, the way that you typically do this, for example, if you're an appraiser and you're looking at the outside of the house, you may very well take your old Stanley tape measure or whatever tape measure you happen to have, a long one. You'll take a piece of paper and you'll diagram the house as you walk around it, and you'll put the measurements down. So what's happening here is that they're presenting you with a couple things. You're saying, okay, the front door might be located right here on the house. Okay? This might be where the living room is. I'm kind of making it up as we go along. I go from here to here and I measure, that's 100 feet, and I write that down. I measure from here to here, and that's 40 feet. I'm at the back of the house now. I measure from here to here is 65 feet. I don't have a measurement for this. I measure from this corner to here, and that's 55 feet, and from here to here is 10 feet. Okay? If you'll notice, just from a technique standpoint, what they do then is they divide this up and they number this S, R, and T. And you may say, where did they get the S, R, and T from? This is actually what they're trying to do is say this is a square, this is a rectangle, and that's a triangle. Okay? What you're doing is you're taking something that's a large area and you're breaking it down into little itty-bitty problems, and then you're solving each problem and adding it all back together. So, how do we do this? First thing is you'll notice this is 100 feet by 40 feet. Okay? So, if I take, for example, if I want to know the distance from here to here, from there to there, what I do is I take the 65 feet here and I take away from, let me see if I do this. You know what they did here is this is a problem right here. This is what's throwing me. See this thing right here? This is 40 feet. Okay. I'm looking at this thing. This is 40 by 40. I think that's an error. Okay. If I take the 40 feet minus the 65 feet, that's here. So I take 40 minus 65. Okay, that works out to be, help me out here, I believe that happens to be 45. Okay, so if I take 40, let me write this down here, 65 feet minus 40, okay, that's 2, that's 25 feet. Okay, so what this is essentially telling me here is that if I know the distance from here to here is 65 feet, and I know the distance from here to here is 40 feet, that means that this distance from here to here happens to be, for the lack of anything else, 25 feet. Okay? Now the next question is, now that I know what this is, now I go down here and I look at this as being 40 feet, and I want to know what's the distance between here and here. Well, I know this is 10 feet, so what I do is I take the 40 feet, which is here, minus the 10, which is 30 feet. So now I know the distance between here and here is 30 feet. I know I can't see you. I know I can't hear you all jumping up and down with joy and saying great. But now I know what the rectangle is. Okay? So I know what the size of the square is. I know what the size of the rectangle is. I know if I want to figure out the area of the property, it's 40 times 40 to figure that out. If I want to figure out the area here, I know it's what? 30 times 25. The last thing I have to deal with is this. Well, since I know that from here to here is 55 feet, okay, and I know the distance between here and here happens to be 25 feet, what I do is I take this away, 5 from 3, 5 from, 2 from 5 is 3, so that's 30 feet. So now what I do is I know the distance between here and here is 30 feet. Okay? Again, I don't hear you yay, so I know the problem here is this is 30 times 30. Okay, 30 times 30. Okay? And then what I do is I divide that by 2 because of the angle. Okay? If I had done it as a rectangle, it would have gone out like this. Okay? And what I'm really doing is I'm just dividing this in half. That's where that comes from. Okay? Hopefully I see everybody going, yay, this is great, I understand it. Okay, really simple. So the concept is we've taken a big problem and reduced it down to a little problem. You know, and I know from a mechanical standpoint, sometimes people will wonder, especially if you're mechanically inclined, you know, how do you solve things? You know, like they walk out and they see, like if I'm working on something at home and they see an engine completely torn apart and they go, how in the world does he ever get that thing apart and get it back together again? Well, what you do is you reduce everything into small little problems. And then you can keep track of it. And you do a lot of things that are not obvious. You write down the answer when you find it. You tag stuff. You do all kinds of things that help you take things and solve the problem. It's just a mechanical approach. Now that we know the sizes, what we need to do then is we need to figure out the square footage for the for the S, the R, and the T. So the first thing is we say, okay, this area here is 40 by 40, so 40 by 40, we'll figure it out by the length times the width. We know that its area is 40 times 40, or 1,600 square feet. So we know how big that is. Now that we do that, we take the next problem, which is the center one, which is the rectangle, and we say, well, wait a minute, we figured out what that was. We know that that was 30 feet times 25 feet. We did the math with that, and we came out that's 750 square feet. Just put it in the calculator. The final thing is for the triangle, we came down here and we said, wait a minute, it's 30 feet high, 30 feet wide. What we're going to do is the formula they told us to use is take, excuse me, the area which is the base, which is this here, going down like this, or the base is going this way, I'm sorry, times the height, okay, and divide it by 2. And so what it comes out to be is 450 square feet. So now we know what the size of each one of the areas happens to be. When we get all done with that, we just add it up. We just say the area of S is 1,600 square feet, the area of R is 750, the area of T is, 450, total 2,800 square feet. Okay? And we may be actually calculating that to confirm the living space. We may be calculating that to try to figure out, for example, how much new flooring we need. We may be doing that because we're trying to figure out the size of the property because the lot is irregular. Okay, there could be a lot of reasons why we're doing this calculation. Okay? If for no other reason, because you have to on the math or on the exam. The next thing is where you're going to run into something called volume. Okay, volume. And what this is, again, this is talking about where you're going to get ready to do things like rent a space, if you will, for you to store stuff. Okay? Now, if you really think about it, if you go to some of the stores, like you go to Home Depot, you go to Lowe's, you go to Costco, you see that you're really in some kind of a warehouse environment. You see that they're concerned about not only the stuff that's on the floor, but all of those places, even down to the fact of Borders Bookstore, Barnes & Noble, they're looking at how high they can store stuff. So, excuse me, when you're looking at that warehouse space to rent, you're not only looking at the floor space, you're saying, well, how high is it? How high can my racks go that I'm storing stuff? That's why when you go to Home Depot, and you go to get a refrigerator or a freezer or whatever, it may not be right here, but the guy will come out with the forklift and go up and get whatever the thing is that you need and bring it back down, and then you can take it home. It's that vertical storage, it's that capacity. So you may very well be talking about when you're storing stuff. Now, where are some of these things? Warehousing would be one place, mini warehousing where you would store your stuff, parts warehouses, especially nowadays, a lot of these depots, if you look at even down to places like a barn, where you have distribution centers, all that stuff is automated. They have racks where computers are going in and pulling stuff off the racks and putting them on conveyor belts and sending them down and packing them and sending them out. Those places are all concerned about capacity, how big, how much volume you have. So again, what you're really doing here is you're talking about the volume is equal to the length times the width times the height. The idea is that you have something here that happens to be 10 feet wide. This would be like a little mini warehouse where you're going to put stuff, while you're moving. So 10 feet wide, 10 feet high, and 15 feet long. And when you figure that, when you do the volume, it's 1,500 square feet, or 1,500 cubic feet. We also use cubic feet, not that we're selling refrigerators, but we use it in refrigerators, freezers, places where we store stuff, if you really think about it. If you go down to buy a refrigerator at Sears, they won't talk about square feet, they'll talk about cubic feet. They'll say the refrigerator has this much cubic feet storage, the freezer has this much cubic feet storage. So cubic is always associated with storage in my mind, at least. Okay, the next thing that they're talking about in here is something called Huber's pyramid. Huber's pyramid. Okay. Now, Huber, who's the author of the book, did not invent this pyramid. Okay, did not. A lot of different disciplines use this conceptual idea of a pyramid to solve a problem. I think I've mentioned this in previous classes. In the electrical business, electrical systems, you have where you'll have something up on top, like you had volts, resistance, and current. The whole idea here is that you have, instead of you having to figure out algebraically what the answer is, doing the math, what you do is you just plug stuff into the triangle, and then you cover up the area in which you're looking for the answer. Okay? A couple things I want to point out is when you're looking at this triangle, notice that, and I'll just point this out, notice that on this side you have some kind of a letter that's designating something that you are, some kind of a thing that you're doing the math with, just for the identifier. Notice that there's a cross in between. That means multiply. Over on this side we have another quantity. Up on top, notice that there's a division between the bottom and the top. Okay? So what I'm trying to say is that if I'm looking for something, I cover up the quadrant in which I'm looking for. So for example, if I am looking for something that's in here, I would cover up here, which means that the answer to that, the unknown quantity, I take whatever is down the bottom and multiply it. If I'm looking for something here, I cover this up, and it tells me to take the bottom and divide it by the top. Okay, and this will become obvious as we go along. Okay, this is the way that we work. Okay, so bear with me on this. So where do we start? Okay, the first thing is we need to know or need to understand when we read a problem what it really symbolizes. In fact, not to confuse the issue, but if you take any accounting classes at all, one of the things that you're going to find out is that accounting classes are not hard. The math is not hard. Most of the time in accounting classes, the math is addition, subtraction, multiplication, and division. The hard part in an accounting class is figuring out where to put stuff. In other words, is this income? Is it an expense? Is it an asset? Is it a liability? What is it? So what we learn in accounting is where to put the stuff. Not how to do the math, but where to put the stuff. Okay? Now, in order to do that, they've put together this little thing over here, this little factors that you need to know. And we want to spend a little bit of time, and this is going to come up when you read when you're reading a word problem. Notice that what we have on the top here is we have made, paid, and rate. Okay? So when we talk about things that we make or made, we're talking about we've put some kind of an effort out, some kind of work, and we've made something. Okay? So made would be things like a return. In other words, we put money in the bank, the money sits in the bank for a period of time, and the bank turns around and pays us interest. Okay, that would be something we made. Like, for example, if I put $1,000 in the bank at 10% interest, and at the end of the year the bank paid me $100, which would be 10% of $1,000, that's what I made for them using my money for a year. That's made. Profit has to do with something where you buy something hopefully at a low cost and you sell it at a higher cost. Okay? So for example, if I buy a house for $100,000 and I turn around and sell it for $200,000, then the money that I made is called profit. I'm leaving everything else. I'm just conceptually meaning, in other words, I have a price that I paid for something, I sold it for another price, and what I made was called profit. Okay? Some of the other things would be like commission. A commission would be, for example, if I sell a house, and again I'm going to use a very simple number so I can do the math, but if the house is for sale for $100,000 and I sell it and my commission is 6%, then I make $6,000. That's how much I have made as a result of selling the house. Made. Okay? Net income. Net income means that I have something that I've sold, I've had some expenses, and that's what the result is. Okay? So for example, maybe I have a rental piece of property and I rent it out, let's say theoretically for a month. Make it easy. It's $1,000 a month. And maybe when I've rented it out, that's how much money I've made. Now, in order for me to make that, I've had to pay some expenses. Maybe I've paid for something like water, sewer. I've had some maintenance that I've had to do. And maybe my expenses that I've paid out for that is, I don't know, say $500. So my rent was $1,000. My expenses were $500. My net income that I put in my pocket and walk away is $500. That's what we mean by net income. And then interest. Interest is something that we make. When we put money in the bank and it sits there, the bank pays us interest. It pays us, actually interest is kind of like rent for using our money is what it is. Now that's what's made. That's what we made as a result of our effort. Paid, when we see this in a word problem, this would be things like, hey, how much money did you invest? How much money did you invest in the property? How much money did you give to the bank? Okay, that's what we talk about investment. Cost would be what did we pay for it initially? Okay? Price would be what we paid for it. Value would be another thing. What did we pay for it? Value. And finally, principal. Principal happens to be, okay, we borrow a certain amount of money. That's the principal amount. We're paying interest back to somebody. Finally, when we look at rate, rate usually has some kind of a percentage in the name. Like rate of return, rate of profit. Usually they'll say, hey, you made a 10% profit, a 10% rate of return, a 5% rate of return. That's what we're talking about. So we want to have an understanding of what those terms are. Okay? Now going back to the pyramid, what I'm going to do is show you a couple examples of how this works, if I can remember this, just to get you going in this direction. They have a pyramid here. And let me see what they did. Okay. Here's an example. Your agency purchases a lot for $9,000. In selling it later, you made a profit of $3,000. Okay. What was your percentage of profit? Okay. So the question is, where did I put the stuff in? What are they looking for? They're looking for a percentage, which means that they're looking for, this is the unknown quantity. We don't know what that is. We have no idea what that is. We do know that we paid, in this particular case, we paid how much? We paid $9,000. We made $6,000. So what we essentially do is over here, and I'll write in my book, we put up here, this is what we made, $3,000. This is what we paid, $9,000. If we put that into a calculator, those are the quantities. So what we're looking for, we put our thumb over. That's what we need. And in order to solve that problem, we have to put 3,000 divided by 9,000, and that gives us our percentage. You may say, well, how does that work? So I'm going to show you on the calculator. What we're going to do is I'm just going to flip over here. I think I already have a calculator up here somewhere. So again, once we understand the problem, the math is not that hard. So in this particular case, what we're going to do is we have $3,000 went in the top part of the pyramid. We're going to divide that by the 9,000, which is here. And we're going to hit the equal sign. And it tells us what the percentage happens to be. And I think that's what it is in the book. And it's 0.33333333. And we round that out to 0.33. Okay? But anyway, that's the point. Once you understand the math is not that hard, what it is it's setting the problem up. Okay, we'll do more of those as time goes by. Okay, let me go back to here. All right. The next thing that becomes important from a math standpoint, and this is just setting all this stuff up so we can do the problems, is we need to know how to convert decimals to percentages and percentages to decimals. And so what they do here is they give you an example. And the reason why is, let me see if I can give you an example. I may go to the bank and they're telling me that I'm going to earn 9% interest on my investment. Okay? I go into the calculator. I may very well have a calculator that doesn't have a percent key, or I don't know how to necessarily use it. And so what ends up happening, it's not like I can hit a number and hit percent and it gives me an answer. So I need to know how to convert that stuff back and forth. So what they're essentially doing here is they're saying to you, if you have, and I'll see if I can blow this up here a little bit so we can see this, is that if you are given a number like 9.5%, what you need to do is you need to move the decimal point over 2 places. So essentially what ends up happening is you put another 0 right here and you put the decimal point here. That's what that is. So if I was going to put that into a calculator and I wanted to figure out 9.5% of a certain amount of money, I would put in 0.095. Okay? Same thing here. I may very well turn around and have a number and I want to convert it to a percent. I do just the opposite. If I want to convert 1.2 to a percent, which means it's more than 1, I put a decimal point, I put a 0 here and I move it over here, and that becomes 120%. The last one is that I have here is 0.9. A lot of people think that 9%. What I have to do is I have to move it over. It's always move the decimal point left or right 2 places. So that'd be 0.9%. Okay? And they give you an example of how that would work down here for these other ones. Okay? In this case right here, you're moving this. You would convert this percentage to a decimal by putting a 0 in here and going over 2 decimal points, which would be this. Same thing here. You have 0.5. If you wanted to go the other way, you would move the decimal point over this direction, which ends up in that. So it's always move the decimal point 2 points to the left or 2 points to the right, depending upon which way you're going. Okay. Okay. I think that's pretty much it for right now on that. That gives you enough of how that works. The next thing that they talk about, getting near the end of this particular thing, is that the commission, just so you know what in the world this is, what it's doing here, this is just no more than saying, one of the things that you may very well be doing when you sell real estate is you may have what we call a commission split. So you want to understand how that works. And you may say, well, where is that going to be? Well, in real life, when you get ready to sign your contract to go to work for a broker and the broker tells you you're going to earn a 50% commission on your portion of the sale, you're going to go, 50% of what? You're going to be sitting down there with your employment agreement and trying to figure out, if I sell a house for $100,000, how much money am I really going to get if I list it but don't sell it? What am I going to get? So the point of this problem is trying to explain how the commission split works. As an example, you have a property that you sold and the commission is $6,000. Now, I can do this off the top of my head and probably if you've earned $6,000 and you're at 6% commission, you sold the property worth $100,000. Okay? This $6,000 is the total commission that is paid by the seller. Okay? Now, what happens is that if you happen to be the agent that lists it, but another company sells it, then that commission is split 50-50. So for example, if I worked for Century 21 and I listed the property, but Lion Realtors sold the property, then my brokerage, my boss, my broker, would get 50% of the $6,000 or $3,000. The other broker at Lion Realtors would get 50% of the $6,000 or $3,000. So that's what the broker gets. Now the split that I have, so again, this is showing your particular agency. Again, this could be Century 21, this could be Lion, whatever. Now, after you've done that, then how much of that money you happen to get is based on your employment contract with the broker. If the broker comes down and says, okay, well, what's going to happen is we're going to pay you 70% of whatever the commission is that you earn, okay, that we earn, then you take 70% of the $3,000. That's what you're going to put in your pocket, and your broker is going to get the $900. Okay. Conversely, you could be working for this other company where you're on a different split. In this case, the brokerage receives $3,000, but your share of it is 60%. So you're going to earn $1,800. Your other broker is going to, or the broker themselves, they're going to have the remaining part, which is $1,200. You just want to know that. That's why, and you're going to need to know that because when you're doing things like planning how many houses you need to sell in a year, how many properties you need to sell, you have to say, okay, well, based on my, the properties that are in the geographical area that I normally would sell, roughly average about, and you would know, $300,000 or $400,000, $200,000, whatever it is. The commission on those kinds of property is 6%. My contract with my brokerage is that this is how much I earn. So that'll dictate to me. I know how many. If I want to make a certain amount of money, I can do the math and say, okay, I need to sell, 10 houses this year, or 15 or 20, whatever it happens to be. So you know what you need to do in order to earn that amount of money. Very important. Okay, now let's go through an example here. I think this will go through the pyramid. Okay, and let me see how many of these there are. Okay, I think there's quite a few. Okay, yeah. Okay, first of all, when you see a problem, and by the way, these problems that they have in here, are these real? Yeah, you're going to have problems like this. The funny thing is they're giving you the information. In the real world, you may have to sit there with the client and dig this information up, or you may have to call the title company or talk to somebody else to actually find the information. But here's what's happening. Mr. Smith sold her home for $250,000. Let's see if we can blow this up so we can see it better on TV here a little bit. Okay. Ms. Smith sold her home for $250,000, which was 8% more than she paid for it. Okay? For the property. By the way, knowing these problems is critical to being able to solve the problems on the exam, the one that I give you. So when you read the problem here and you understand how this works and you get the problem that you do on the exam, that way you'll know how to approach the problem. Okay? So Ms. Smith had $250,000, which was 8% more than she paid for the property. So it's obvious from that statement that she paid less than $250,000 when she bought the property. We don't know what she paid, but we know she paid less, which was 8% more than what she paid for the property. How much did Mrs. Smith pay for the property? So that's the question. If she made an 8% increase, what did she pay for it? So what we need to do is we need to know where to put this stuff in the problem. Where in the Huber pyramid does this stuff go? We happen to know number one is that they've given us a percentage. We know percentages go in the bottom. By the way, it doesn't make any difference whether it's on the left or the right, but you don't put a percentage up here, you put it on the bottom. We know also that she sold it for 8% more. Now, the 8% more assumes that she's selling it for more than whatever she bought it for, so it's got to be greater than 100%. Okay? So what she sold it for was 108, so we put 108% here. Okay? Now, the next thing is we have $250,000. This $250,000 is what she made. Okay, this is what she sold it for. Now, in order for us to solve the problem, that's where the question mark is right here. That's where our thumb needs to go over. We need to know what is it that she actually paid for the property. And it gives you the solution. It says, remember that the profit is always a percentage of the cost. If we use the Huber pyramid, know the selling price made is $250,000 and the rate is 108%. To find what we paid for it, we just divide this by that. Okay? And how do we do that on the calculator? It's pretty straightforward. I mean, once we identify what it is that we need to do, we just go in here and we have $250,000, 250,123, divided by, and the percentage happens to be 1, 0.08, okay, hit the old equal sign, and that gives us the answer, which is 231, which I think is pretty close to what they have in the book. Okay, that's how the problem is solved. Okay, now that we understand how that one problem is solved, now we should be able, with that approach, should be able to solve any problem that fits that criteria. Anytime somebody gives us a question and says you sold the property for this, you made this kind of a % profit, what did you pay for it? We now know how to solve that problem. We need to put that in our tool bag. That's our crescent wrench, our ratchet, whatever. That's our tool to solve that problem. Okay? The next one, the next problem that we have here, and let me flip back, okay, is this one here. Right? Let me see, I think I need to go one more. All right, one more after that. Okay. Here's this problem. Okay. Example, Mr. Bush bought a new home on January 14th for $280,000, brand new. Okay. On July 6th, he was transferred to a new city and sold his home for $270,000. So it's obvious that he lost money. It doesn't take a rocket scientist to say, I paid this and I sold it for this and I lost money. We know right off the top of the head that if he paid $280 and he sold for $270, he's lost, barring anything else, he's lost, what, $10,000 on the sale. So now what we need to do is finally it says, in a new city, for his home, what is his percentage of loss? So what we know is that what we're looking for is a percent. We're looking for a percent. So what we know from this is that in this case, he did not make money, he lost money. You know, we know he lost money because he bought it for $280 and he sold it for $270. He lost $10,000. So in the made category, we put that he lost $10,000. We know that what it cost him to buy it was $280,000. We know what we're looking for is a percentage. That's where we put our thumb over. If we do the math, we take the $10,000 divided by $280,000, and that's going to give us our percentage. It tells us right here that that happens to be a 4% interest rate. Let's just see if that's true. Again, this is the approach, how you approach to solve a problem. You know, basically what's happening is we have up on the top of the pyramid is 10,000. I think that's correct. Divided by what he paid for it, which was $280,000. And we hit the old equal sign, and that happens to be 0.035. And any time that it's 5 or greater, we round up to the next number, which happens to be 0.04. We move the decimal point over 2, and it's 4%. Okay, so what's happened is he's lost 4%. Right? The other thing to keep in mind, too, is if you remember all the way back in grammar school, or in, say, 2nd, 3rd, or 4th grade, they taught us, they said, you know what, you can always check your work. For example, if I have a number and I want to check my subtraction, so I have, I bought something for $10, I sold it for, I paid $3 for it, and I made, so it's 10 minus 3 is $7. If I want to check my answer, I take the 3 and the 7 and add it back up, and it should come up to be the 10. So the point is that anytime once you know the answer, you can work the formula backwards to check your work. So you could actually take the 4% times this or divide this by this in order to find out that answer. So that's what we're saying. You can double check your work that way. Okay. Now, getting close to the end here, the next thing that they're trying to do here is in the rate of interest problems. And by the way, unless you are given something separate, like a chart or some kind of a calculator, you have to make the assumption that all interest that they're asking you to calculate is simple interest. It's not compounded interest, it's simple. Okay, simple, not compounded. Compounded means, like, for example, if I'm compounding interest, it would be like, for example, this year I put my money in the bank, they pay me 10%. I put $1,000 in, 10%. At the end of the year, I have $1,100. The original $1,000 plus the $100 interest. If they're continuing to pay me 10% next year, they're going to pay me 10% of not 1,000, but 10% of 1,100. Okay? So keep in mind, compounding is where you're adding to something, right? Now, when you're working with interest, you add into this pyramid a new quantity, a new thing. You have to consider the fact of time. Time. So, for example, if I borrow $1,000 from the bank and my interest rate is 10%, that means if I borrow it for 1 year, it's $100 interest. If I borrow it for 2 years, it's $200. If I borrowed for 3 years, it's $300. So when I'm asked a question like how much was my interest that I paid on a house on a loan that I had for 3 years at 10%, I have to consider the fact that I have to figure out what it is for 1 year and then multiply it times the number of years or the number of periods. So that's what this is doing. It's adding the one more thing in, which is where we have here, which is principal, rate, and this is time. We have to consider the amount of time that you have it. Okay? So they're giving you an example here. Okay? Giving you an example. They're saying that you're going to calculate how much interest was paid. How much interest was paid or made. What happens is that the principal was $10,000. I don't know whether you can see that or not, but I'm going to blow it up here a little bit more. What you're trying to do is figure out how much the interest was. So your principal was $10,000. Your rate was 9%. You did that for 2 years. So it would be principal times the rate, which would be $900, if you do that in your head, okay, times this, which happens to be 2 years, which is $1,800. So that's how we came up with that figure. Okay. The question is how much interest have we paid? Okay. After that, we'll go through some other problems where we're looking for other kinds of unknown quantities. Okay. In other words, where what's really important, and I'm going to mention this the next time because what I'm going to be doing the next time is going through the problems at the end of the chapter. There's 10 problems. And what I'm going to be doing is I'm going to apply these techniques to those problems. I would expect between now and then you're probably going to go ahead and read this, work through the problems, understand what the approach happens to be. The concept is you have a problem that you want to solve. You go back in your mind, you say, where have I seen that done before? You look in the book, you take a look at it and say, oh, on page 542 shows the answer, how they solved that problem. That's the approach they used. I take that approach and I apply it to this new problem. And I solve the problem in the same way. To me, it's no different than the fact if I'm getting ready to work on a car, I look at something and I say, I need this kind of a tool. Whatever that happens to be. I need a wrench, I need a socket, I need a pliers, whatever it happens to be. So what I'm really trying to do is figure out when I look at a problem, what are the tools that I need to do to solve the problem? And that's the idea why we're looking at these different kinds of approaches, if you will. So again, the next time I'm going to be going over the questions at the end of the chapter and applying these particular principles that we've learned here. I'll go one by one and make sure that you get it. And then you're going to want to do that in order for you to study for the exam. Very, very important. That's the biggest area where people fall down on their exam. With that, I want to thank you very much for watching, and we will see you back here the next time where we'll finish up the rest of the math lecture. Thank you.